Hello everyone. For our second lesson today, we are going to find the area of overlapping regions by using principles of unions and intersections. A union is where we put two shapes together. And an intersection is when we have overlapping parts of shapes. So one application for when we may need to find the area of a union or an intersection is if we were trying to paint a mural and we were trying to find how much paint we would need for overlapping shapes. Can you give one more example in this box of a time in real life where you might need to find the area of intersecting shapes or a union of shapes? Awesome. So we're going to move on to our notes section. This first notes question says, two congruent triangles are shown below. Calculate the area of each triangle. Then circle the transformations that, if applied to the first triangle, would always result in a new triangle with the same area. And then they want you to explain your answer for part B. So go ahead, pause this video, and work on that. Great, so hopefully you have an answer for each of these things. I'm not going to solve these the entire way. There is a Khan Academy video posted that will help you if you don't remember how to find the area of a triangle. But basically what you need to know is that area is 1/2 base times height. We've done this before in the past. Now thinking about transformations that keep shapes the same, we know that our size stays the same as long as we're using a rigid transformation. So if you struggled with this question, maybe you want to go look for some articles on rigid transformations, and hopefully that'll be a refresher for you so that you can figure out which ones of these will leave our triangles congruent to each other. So after that quick review, let's look at this shaded figure. We're calculating the area of the shaded figure, and this is what we call a union with no overlap. We call this a union with no overlap because each of our shapes are next to each other, but they don't overlap each other. They're not on top of one another. We have three shapes here. We have two triangles and a rectangle. Now we know the area formulas for those two triangles and the rectangle. The area of a triangle is 1/2 base times height, and the area of a rectangle is just base times height, or length times width. So if we don't have any overlapping sections, all we have to do is find the area of each piece and then add them together. So if we're explaining how we're going to do this, we're going to find the area of each piece, and then we're going to add the areas together. So to find this area, this is a triangle. We know our base right here is 3. We know our height here is also 3. So that means area being 1/2 of the base times the height. If we put this into our calculator, we get 4.5. This triangle is exactly the same, so we know this area is also 4.5. This rectangular area, we just multiply the length and the width. We know that the length is 7 and the width is 3. So we know the area here will just be 7 times 3, which is 21. So everything I just did was that first piece. Find the area of each piece. Now we're going to add our areas together. To do that, we just need to do 4.5 plus 21 plus 4.5. You can do this by hand or put it into a calculator, and you should get 30. So we added our areas together, and 30 is our final answer. Just as a review, let's go to the bottom of this assignment and add this information on our review cheat sheet. So union without overlap is when we're adding several shapes together. This is actually the same as union with overlap, and we'll talk about that in just a moment. So union without overlap, we're adding several shapes together, and we find the area of each shape. Then we add the areas. Now let's talk about union with an overlap. This is the only type of problem in this lesson that you have never seen before. So let's read this question. Two triangles ABC and DEF are shown below. The two triangles overlap to form triangle DGC. What this is saying is we have this small triangle here that's overlapped, so it's in both of the larger triangles. So we have a little bit of a problem where if I were to find the area of this large triangle, and then if I were to find the area of this medium-sized triangle, and if I just added them together, I've counted this middle part twice. So to counteract that, we find the area of the middle part and we subtract it once, so that we're only counting it once. Okay. So first let's find the area of the big triangle. This is a triangle, so we're going to use our 1/2 base times height formula. So area is 1/2 of 4 times, we don't know what our base is. So let's look here at the bottom. It says the base is composed of segments of the following lengths. AD is 4 and DC is 3 and CF is 2. So if I'm looking at my red triangle, this really large triangle, then the base of that is the 4 and the 3 put together. So if I put those two together, I get 7. So my base is 7, and my height is, of course, 4. So 1/2, 7 times 4, that's 14. Now let's find the area of the green triangle. So here, just like with the red triangle, I don't know what my base is yet. Here my base is the 3 and the 2 put together, which is going to be 5. So my area of the large triangle is 1/2. My base is 5. My height is 2. And that means that my answer here is 5. Now remember what I said before, that we have to get rid of that overlapping part, right? Because we counted the overlapping part is in this 14 and it's also in the 5. So we have to get rid of it once. So to do that, I need to find my overlapping section here. Now the base of this overlapping section is 3. My height is 0.9. So to find the area of the small blue overlapping triangle, I do 1/2 times 0.9 times 3, and I get 1.35. Now to get the entire area, what I do is I find the area of each shape. I add my large areas, and then I subtract the overlap. So we already found the area of each shape. Now I'm going to add my large areas. So my large areas are my 14 and my 5. 14 plus 5 is 19. And now I subtract my overlapping section, which is the 1.35. So I subtract 1.35 and I get my answer, which is 17.65. Let's review and put this in our chart at the bottom of our page. So the definition of a union with overlap, we're still adding several shapes together, but we also have an overlapping section, right? So it looks like the problem we just did. And to do this, if you remember, we found the area of each shape. Then we added the large areas. Then we subtracted the overlap. Now let's move on to our final example. And this is what we call a difference. So a difference is where we have one shape taken away from another shape. In this instance, we have a large gray rectangle, and we're taking away a triangular portion. So to find the area of our rectangle, we're going to use the area formula, length times width, and that will be 21.6 times 12. We get 259.2. Now we need to find the area of the triangle. So that area will be 1/2 base times height. Our base is 9.6. Our height is 7.2. So if I'm finding that area, I get 34.56. Now to get the shaded region, I have to do one more step. The first thing I did was find each area, right? Find the area of each shape. Then the second thing I'm going to do is subtract the non-shaded area. Okay. So to do that, I'm just going to take this, which was my large area, and I'm going to subtract my 34.56, which was my small area. So I'm going to do 259.2 minus 34.56, and I get 224.64. Let's put that into our review box. So the definition of a difference is when we are taking away a portion of the area. And the math that we have to do, first we find the area of each shape. And then we do the area of the outside minus the area of the inside, right? Then we subtract. If you have any questions or problems with this, go ahead, you can leave a comment on this video, you can ask a question on Google Classroom, or attend a coach class. Good luck!